record. Here we go. Okay, so multiplying by a rational expression. Now remember, a rational expression, all that ever is just a ratio of two polynomials, right? So rational expression, ratio of two polynomials. Remember, a polynomial follows this form, where that's a whole number. So you can't have like x to the -5 or x to the 1/2 power. It's got to be x raised to a whole number. Okay, that and a collection of those is a polynomial. So let's look at A5. It says here, review your work from yesterday by simplifying. Okay, so we got to simplify this. Okay, and also state what are the excluded values. So we got to do two things. We got to simplify and state the excluded values. What do you think I should do about this problem? How should I go about this? What should be my approach to simplify? What's the big thing we've done? I'm thinking you guys in Algebra 1. When you have a quadratic, what do we usually try to do to make it look more simple? Starts with that. Sorry, I'm not asking the question correctly. Factor, yes, factor. So we want a factor. Very important. I still owe you guys this document. It's factoring flowchart, which I think actually maybe I'll print a bunch right now and I'll give it to you guys. So this will be so you may want to put this somewhere in your binders or notebooks. Yeah, let me make 30 of those. There we go. Clearly I have three terms. There are no common factors. The first and last terms are not perfect squares, but a leading coefficient is 1. So I'm going down the flowchart, right? Three terms. Common factors, no. First, last term, first squares are not either. There's 2 and 3 as the leading coefficients. Then is the leading coefficient 1? No. So we have to use like that diamond / grouping or area model, whatever you want to do. So let me pull that up right here. Here we go. Yep. So let me go and clear my screen and let's get carried away with the factoring here. So we'll start with the first one. Let me zoom in because it's hard to read. All right, much better. Here we go. Yeah, so let's go and factor that first one. Remember I do the diamond, right? How did I do the diamond? Do you guys remember what I put up top? What number did I put up top? Yeah, you put the a times c, which is -12. You don't have to put x squared. Just put -12. It's fine. And what do you put in the bottom? Yeah, it's just a middle term, right? And again, you don't have to put the x. You could just put the numbers. It's fine. Now, your task. What two numbers multiply -12 and add to 11? Add to -12 and sorry, multiply -12 add to 11. There's only a few options. Like -1 and 12, -2 and 6, -3 and 4, or the reverse. Which of those would make sense for us? -1 and 12, exactly. I mean, and by the way, if you write all the scenarios and none of them work, then it's not factorable. But I'm going to make it factorable because I want you to cross stuff out, right? Remember, I write this cross for I want them to factor. If none of those three worked, then just switch the signs. Make one positive, 12 negative, vice versa, right? So anyway, now you have that. But before I do that, let's also do it for the bottom as well. Let's change color. Let's go to green. Spirit of Christmas. All right. No common factors, unfortunately. 2 and 12, 24, 11. What two numbers multiply 24 and add to 11? Perfect. That's an easy one. The negative ones are always kind of weird. A and 3. Thanks, Doug. So now I'm going to do a area model just to be consistent with what we've done in the past. So I'm going to put 3x squared and -4 and -x and 12x. Because again, the whole point of doing a diamond is a split the middle term, split 11x. So those two terms, you put them into that other point. And we're going to get back to the first round. What's common in the first round? Totally. How about the, so if that's 3x, I can't do 3's here. Stylus 3x. Then what goes above? What goes in the upper? Basically, what goes up here? What goes up here? That's good. Yeah, and then fill out the rest. What are the other stuff here? -1 and probably 4, right? So you got 3x minus 1 and x plus 4. Perfect. Now let's do it again for the green. Area model, 2x squared, 12, 3x and 8x. What can I factor out of the first row? First row, 2x, good. And that'll be x up here, and then keep going. 3 and probably 4. Okay. So I got 2x plus 3 and x plus 4. What do you know? What crosses off?
X plus 4.
Yeah, and that you can do because each of those x plus 4 is being multiplied to the other groups. So that is okay. You can actually cross off this way. The final answer is 3x minus 1 over 2x plus 3. So that's how you would simplify it. Definitely looks more simple than it did originally. By the way, if you know how the top factors, I didn't really need to do the area model if I didn't want to. I could have actually just realized, well, 3x minus 1 can't be pulled out of this, right? But x plus 4 probably could be pulled out of the bottom polynomial. That means that this has to be a 3 and this has to be a 2x. So sometimes you kind of suspect what factor is going to go away. Because 3x minus 1 can't be. How can I have 3x and that's 2x squared, right? That doesn't make any sense. So you kind of suspect that that's probably one that's pulled out. If that's pulled out, then of course this has to be a 3. Oh, this has to be a 2x. So sometimes you could use, you could be kind of introspective about it in some ways if you want. You don't have to kind of go through the entire process.
But we have to factor out like cube root equations.
I'm gonna keep it simple. I'm gonna keep it quadratic for you guys.
Well, we won't have to do that for the whole unit. Or
for this unit, so we move in the polynomials next unit. There for sure we do. But this unit, I think we're gonna keep it quadratic. Yeah. Now, what's excluded? What is excluded? Obviously, x can't equal -4. Even though you crossed it off, originally it would be a problem because it would still be 0 in the original expression. And also, it can't be -3/2. How to get -3/2? What? How did I know that so quickly? Yeah, go check. Yeah, I just did that math in my head. I set this equal to 0. So move the 3 over, divide 2, boom, 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 done. Right? All right, let's move on. Let me clear the screen. All right, here we go. Moving on. So this is with your team, review responses, blah, blah, blah. We'll just do these problems. Definitely have you guys do 87, 88 in your groups so you guys can practice that. But let's take a look at these here. So this is a nice kind of segue to the last two examples, 87, 88. Because you guys got to remember how to multiply and divide fractions. You got to remember how to do that, right? Don't want that to be an issue. On tomorrow, Thursday, we are going to talk about adding, subtracting fractions. So if you forgot that, don't worry, we'll go through that too. So here, when you multiply fractions, just simply multiply numerators and denominators. So that's all you do. Multiply numerators and multiply denominators.
Don't you do some?
Yes, then simplify.
Can you simplify first? Or?
I'm gonna get there. Yeah, no, you're like close to that step ahead of me, man. Just gotta like that. So this is one way. Multiply the numerators, multiply across, multiply it down below. Now, what do 1842 share? What common factor do they share? They share. I know they share a common factor other than 1. 6, totally, yeah, totally 6. So you get 3 7s, and we're done, right? So that's one way you could have done it. Now, what Hunter was insinuating, which I like too, if you so desire, which actually I think is probably better, can you cross cancel totally? Because if you think about it, if you were to bring these together, technically, it's like this, right? Let's fix that. There's no harm in doing what I just did. Merging these two fractions into 1. You totally can do that. And also reversing the order. Because who cares? 3 times 9, 9 times 2, same thing, right? It doesn't matter. So if you think about what does 9 over 3 reduce to?
Wait, 3 over
3, right. And what's 2 over 14 reduced to?
1 7.
Boom, got it. So yes, you can reduce prior to actually doing the even avoiding multiplication altogether. Some people do this. which is fine. Just be careful, please. So 1 and 7, that's great. 1 and 3, that's great. 3/7, totally fine. You can do that. I'm just gonna warn you. You really want to get my blood boiling? Please don't. I'll have students do this. I mean, I'll give a student a problem like this, and they'll look like, oh yeah, let's just cross those off. Why is that so bad?
There's a plus, right? That's, you can't do that, so please don't do that, right? Only when there's multiplication, you can do that. Because multiplication is opposite division, you're crossing off that's like division. And that's just blatantly wrong.
Right? So don't confuse things, right? Because then you're memorizing math, you're not understanding, and that's not good. You want to understand what you're doing, right? When you're crossing stuff off, that's like division. Multiplication is opposite division. You have that freedom to do that for 2/3 times 9/14. Not 2/3 plus 9/14. Cannot do that. 2/3 plus 9/14. We'll talk about it tomorrow. You have to find the least common denominator. We'll have that conversation tomorrow. All right. For this one, it's not that much different, but one little wrinkle. What's that little wrinkle here? What's that one extra step I have to do compared to the first problem? When I look at 3/5. Go, Hunter. What is that?
You have to reciprocate.
Yeah, you gotta flip the second fraction exactly. That's all. You gotta flip that second fraction. And then you multiply. That's all. Now, when the numbers get large, actually cross-canceling is good. Just be careful again, right? Cross-canceling is good. Because what is 3/12 reduced to? Yeah, and how about 25/5? Boom, got it. Got the answer, 5/4. You made that look way simpler now than the way it was originally, right? That's the whole point. We want to simplify things so that when you do more advanced math down the road, it's going to be easy to do the advanced math when you can simplify stuff prior to doing all these other steps that you'll learn later on in your math career. So, okay, cool. So we're going to apply those same principles to algebraic expressions down below. So let me do this. Let me do A and F. I'll have you guys do B, C, D, E. Let me do A and F with you guys. I'll have you guys do B, C, D, E. So let me do A right now. A right now. Here we go. Well, guess what? Those cancel. So the answer is 4x plus 3 over x plus 3. Can I cancel anymore? No. Some people think to do that. Don't do that, please. Some people, oh, yeah, let's just cross those x's. Don't do that, please.
I was looking at it differently.
Yeah. That is the best we can do. The exponent size canceled. We're good. You're also asked to find same as to make the denominator 0. Obviously, x cannot equal 5, and x cannot equal -3. Because that would be bad, because you'd be divided by 0 in the original expression. So that's part A. Simplify, state what you x values are not okay. Let's take a look at that. So I'm going to rewrite this because we have to flip the second fraction. So that's probably a good idea. Okie dokie. You guys see what I just did? I flipped the second fraction, right? Okay. Now the fun begins. Let's cross stuff off. What can I cross off? And that's a 5, by the way. Sorry, that looks messy. So what can I cross off? You can cross off
Diagonally or top to
5x
bottom,
minus
because it's all multiplication. What can I cross off?
5x minus 2.
Okay, anything else?
I can't.
yeah, and what else? Yeah, totally. See? Now it looks more simple. So final answer is going to be 3x plus 1 over 2x minus 3. Now, very important, what is excluded? Clearly, x cannot be 4, because that would make the second fraction 0 on the bottom. X cannot be 3/2. X cannot be, yeah, I already said 3/2. And when you flipped, you also have 5x minus 2 on the bottom. X cannot be 2/5. Okay, so those are the excluded values because it's whatever makes the bottom 0 anywhere in the process. Beginning and middle, doesn't matter. Any moment where the denominator be 0, you have to exclude it. Like for sure, 3 halves and 4. And after I flip it, yeah, also 2/5 has to be excluded. So, all right, once you guys try B, C, D, E, I'll give you guys about 5 minutes to do that. Then we'll look at 88 together. Then you guys do the homework quiz. So go and try B, C, D. I'll freeze the screen. I'll put the answer up in a moment. Okay, so in your table groups, do B, C, D, E. Talk to each other, work it out. Call me over if you're stuck.
I have a question.
Yeah, fire away.
So, I had a math tutor.
Hey, great.
She taught me a different way.
For what? For simplifying?
It's for doing this one.
Sure, show me.
Well, I didn't really show it, but it's like, you take this. I'll just like, it's like, you find that, and then you have to find which one. Like, I know how to do it, but I don't know how to explain it. So you like find.
You want to find 2 numbers that multiply this?
Yeah, and then
Okay.
that also was this one. Like you see how that's.
It's very similar to what we did. I'm probably more structured. That's all. Honestly, if you could factor the way you're doing it, that's fine. You don't have to do it precisely the way I do it. Don't worry about that.
That's why I asked about the Hubert stuff because I don't know if I do it that way.
That's a different kind of factoring. That will be a different process, so don't worry about it.
We're doing BCD.
B, C, D, E. B through E. Beginning, resume recording. All right. So yeah, so for B, that's just going to be X. Yeah, so you flip it, right? So X plus 2 over 9X minus 1, 9X minus 1 over 2X plus 1, boom, boom, X plus 2 over 2X plus 1. Here, fortunately, 2m plus 3 and 3 plus 2m are the same thing. If you want to kind of rewrite it, you could. 4m plus 7, 2m plus 3, those cancel. So you just get 4m plus 7 over 3m minus 2. For D, y minus 2 cubed, that actually is y minus 2 3 times. So you can write 3 times if you want. And you have y plus 5 as well. Down below is 3y, y plus 2, and y minus 2. Y minus 2 is cancel. So it's y minus 2, y minus 2, y plus 5 over 3y, y plus 2. And leave it like that. And finally, for this one, you flip. So 15x cubed, 3y, 4y squared, 10x squared y. You could actually combine them if that helps. 60x cubed y squared, 30x squared y squared. Those cancel. That becomes x. That becomes 2. You guys just get 2x? Yeah, good. Yeah, just 2x. What is excluded? Obviously, you cannot have x's 0 or y 0 because when you flip, x 0 is a problem as well. For C, m cannot be 2/3 or negative 2/3. For B, x cannot be 1/9. Also cannot be negative half, because that would make the bottom 0 when you flip. And for D, y cannot be 0. Also cannot be negative 2 or 2. And that's it.
Wait, which one was 2x? Was that for E?
E is 2x.
Really? Oh.
Yeah, I think so. What do you have?
I got a big number.
You flip?
Yeah, I did.
And then you do 15 times 4 and 10 times 3? 60 over 30?
No, I didn't do that.
Okay. All right, questions? We're good? All right. Lastly, in the interest of time, Actually, was that it? Oh, there's another one here. Sorry. Okay. We won't do all these. Let me just do the left half of it. I'll do it with you guys, and then we can start the homework quiz. So we'll forego the right half. That's just extra practice if you want to, I suppose. So for A, real easy. You can actually start reducing right from the get-go. Does that make sense what I just did? What's the common factor for the first fraction? For 20 and 22, what factor do they share? For A, they share 5, they share 2. How about the second fraction? What do they share? What common factor, guys? 14 and 35, 7. Yep, so you get 2 and 5. And then you can reduce even more. So you get 4 out of 11. Now, some of you guys may not know. Maybe you do, maybe don't, I don't know. But you can reduce fractions in your graphing calculator. It does it actually really nicely. Show you how.
How do you reduce something that calculator?
I'll show you. Here. Let me clear this. Okay. So what you can do is if you type in 20/22 times 14/35, it's going to give you a weird decimal, right? And I should have put parentheses, by the way, but PEMDAS, if it's doing the PEMDAS correctly, so I'm not worried. I know I got this. Wait, did I do this right? Yeah, I'm pretty sure I got it right. Now, if you hit math, hit the math button, and the first option is frac, it takes the most previous answer and converts it to a reduced fraction for you. There you go.
Wait, what do you hit?
Math frac.
Okay.
That's all. Or I could have done this. I could have taken this and then typed in math frac afterwards, so it would know to reduce afterwards. Oh, I didn't like that. I should have put a parentheses. Oh, it bugged out. Sorry. Let me try it again. Now let's do math frac. Yeah. So it'll do the calculation, reduce to a fraction for you. Just so you know, that's something the calculator can do. Now let's look at C. For C, this is a little more complex because there's a little more going on here than the previous example. For C, we got to flip the second fraction. While I'm at it, I'm also going to do some factoring along the way. What can you factor out of the numerator in the first fraction? The numerator in the first fraction, what can be pulled out? Just 5, right? And what's left behind? X minus 3, right? And then the other one, I'm not sure yet because that's a little more complicated. And just so I don't confuse myself, I'm just going to rewrite the entire expressions after I flip before I do more factoring. Okay. Sometimes you can just do this kind of quickly. I'm going to teach you guys how to be more efficient here with your factoring. Let's look at this one here, the x squared plus x minus 12. I think that factors x squared plus x minus 12. You got to multiply x 12 and have x in the middle. I think that factors. Say again?
X minus, yes.
Yeah, good. And we have an x minus 3 elsewhere, right? So I think I feel good about that. And plus it makes sense, right? X minus 3, x plus 4. Okay. Now without having to do, and let me write that more neatly, my apologies. Okay. Instead of having to do the whole diamond, blah, blah, blah box thing, let's just think about it. I see an x plus 4, right? Well, let's be efficient here. You think I can get an x plus 4 out of this? Maybe. Let's take a chance. Let's just put x plus 4 and see what happens. Let's take a chance. I don't know. Maybe I'm wrong. Maybe that can't be fact. But let's assume there's an x plus 4 here. If there's an x plus 4 there, then what has to be the rest? What has to be right next to it? Like, what would have to be here to make this all make sense? Like, what do you think the first one has to be to get 3x squared? But x, what does this have to be? What times x is 3x squared? Yeah, 3x, yeah, exactly, 3x. Yeah. It's not going to work. It was wishful thinking. Never mind. I thought it was going to work out because then I have plus 1, but it won't make sense. You won't get negative 8x in the middle. So never mind. I'm tripping. That didn't work. Okay. That's all right. I tried. So let's just do this really quickly. I'll put a 12 here, -8, -2, and -6. That's 3x squared. And 4, -2x, -6x. That's x. 3x, -2, and -2. Okay. Okay. So x minus 2 and 3x minus 2. Cool. Now, I do suspect there'll be a 3x minus 2 here, because we do want things to cancel. If it's 3x minus 2, then this has to be x plus 4, actually. Yeah, it has to be x plus 4. Unfortunately, it's not going to cross, the x plus 4s won't cross off with anything, but it's okay. Yeah, it has to be, because you have to get -8 and you have to get 10x in the middle. So that's just more by inspection than anything else.
Wait, what is it? Plus 4 -2.
Right. So I didn't do the whole diamond thing. I mean, if you wanted to, you could, but I recognize that I want 3x minus 2 to be pulled out of the denominator of the first fraction. So I deliberately wrote 3x minus 2, then figure out what the other part has to be. So those cancel. Those cancel. So it's 5x minus 2 over x plus 4 times x plus 4. Or you can write it like this: 5x minus 2 over x plus 4 raised to the second power. That works too. Okay. In the interest of time, I'm going to stop there. I think you guys get the idea. There's still plenty more examples to do, but I think you guys get the idea of what's happening. So you guys have enough to do your homework. Let's start the homework quiz right now. You'll just in your field groups. So it's a group effort, whole group effort. There we go. I got the next one to see. Feel free to use the calculator or notes. You get all the resources you want to do. Yeah, wait, you guys not have. There's another one. I think that's still really So I'm just gonna give it a feature. Yeah. There we go. And if you want to do that,
Where's the domain of that? We set the denominator to 0. No.
Ask questions if you like. I do my best to help you out. And here's the fraction flow chart that you guys can keep as a reference if you want for everybody.
No, if you disagree with the team rates, you could get different, not, you don't have the same answer, your table names disagree. I hope you guys do agree though. And make sure you give an explanation too. Yeah, we'll try to.
Oh, or.
Sure. They're right. You bet that's your chance. Let's put it back. Awesome.
Mr. E,
100, yes, go ahead.
isn't
All right.
the bottom?
Yeah.
It's like heavier than the top, isn't it just a zero?
Yeah, you use a graphic calculator, see, yourself.
Oh, yeah.
Yeah, I mean, you are correct, it is. Because ultimately y equals to 0. But we could graph, graph decimal graphic calculator, yeah.
Oh, I'm still recording, crap. Stop it.